Hello. Oh. Welcome back to ABI-DOS. Last episode, we finished up the last puzzle on this page, Signal Clamper. Cool. Yeah, so this episode, we're gonna move on to the next level, Oscillator 2. 2, what's the first one? Here, Oscillator 1. I didn't actually realize there an I in front of it. Or the back of it. Oscillator 1, huh? What did this do? Oh gosh, this is the one that took me quite a while. It's the one that whenever a plus happens, it searches the next one, and whenever the minus happens, it goes to the whenever a plus occurs, this will move from taking input from signal 1 to signal 2, then signal 2, then back to signal 1. What? Wait, hold on, is this the right solution? No, this is the right solution. Oh, it looks to be it looks to be absolutely incorrect. Yeah, I see why though. Okay, so that's Oscillator 1. Interesting. It's a very interesting little machine. Okay, well let's see what Oscillator 2 is in. Oscillator 2, that is not what I thought an oscillator would look like. But okay. This program illustrates the movement of a particle based on an external directive. Wow. S0 provides a constant sequence of indexes ranging from 0 to 8. S0, what are these dots? No idea. S5 consists of 9 columns indexed from left to right. Okay. Beginning at 0. Read S0 and draw the particle's movement. It starts from the top left corner of the display and advances to the specified column step by step. 6. When the particle reaches its destination, read a new index from S0. Wait, what? So what happens here is, so these numbers indicate what position to move it to. So a 6 here indicates move to position 6, considering this first column is position 0. This moves to position 6. This one then tells it to move to position 2, then tells it to move to position 6, then tells it to move to position 0, then 1, then 2, then 7, then position 3, then position 8, and so on and so forth, and so on and so on. Okay. This is an oscillator? Ooh, we got a pointer mover. Have we ever seen this before? I think we might have. We don't have a pointer reader or a pointer writer, but we have a pointer mover, which, what here? Increases by 1 the position of the pointer from signal X. Looping the screen if necessary. This icon bypasses any looping restrictions. Increases by 1 the position of the pointer from signal X. So why? Wait. Bypasses any looping restriction? What does a looping restriction mean? No idea. So what you're saying is that if something passes through it, say 5, then you get a shift. Yes. It only moves by 1 though. So okay, I'm thinking that what should happen is that a 6 will loop 6 times, and for each time it loops over, this will move pointer 1 forward. Okay, well that works for the forward, but the backward seems a bit weird, right? And also, how do you go from this row to the next? You have to go one entire row down and then the next. Can I do that? Aren't these the movers? Wait, there was one that did that, right? I don't remember where it was, but I think it was a linked list that told us, yeah. A pointer writer, yeah. But that's not what they want. They don't allow me to use that. So I'm only allowed to shift it forward by 1. Looping the screen if necessary. What? Zero means nothing is entered. It's not even a bit of 0, it just means nothing. So every time I move forward by 1, I have to loop 8 times plus 1. Wait, 8? No, 9, because we have 0 to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times plus 1. And then 9 times plus 1 and 9 times plus 1. What? Well, okay, to be fair, once something goes in, it'll go here. So actually from here to the next one will be just 9. The issue is when going backwards, it instead becomes 7. But I don't even... That feels really odd. So, okay, we want it to loop forward by 9 every time there's an increase, and loop forward by 7 every time there's a decrease. Is that what they want from me? But the number here is important as well. See, because a 2 doesn't mean shift 2 times, it means shift until the position is 2 plus something. Aha! Wait a minute, is this mod? Oh gosh, this might be mod. We finally use a modulo. Because position 2 implies that every single column down here is, I think, 9 mod 2. Every single thing down here in this column 2 is 2 more than a multiple of 9. So for example, 56 is 2 more than 54, which is a multiple of 9. And that's because everywhere is 9 bits. And every column, yeah. So that's mod, right? Telling me that this 2... okay. This 2 wants me to shift... Is this to set or is this to... this has nothing to do... This has nothing to do with the actual thing though, right? Like, I know we'll get mod here, but this symbol isn't gonna help us. So if you can hear a lot of crinkling right now. I got like plastic around me. I'm dealing with like plastic bags. Anyway, sorry. Thinking about stuff. I'm just wondering, like, okay, it is really good to be able to know that the value that I reach has to be 6 mod 9, or this number mod 9. 0 is 0 mod 9, which is basically just any multiple of 9. In this case, 180 is a multiple of 9. Question is, how do I test for mod? This only sets it to mod, but how do I test for mod? I divide by 9. No, that rounds it down. How is a modulo what? Oh yeah, no, I just use the mod, right? Because what I can do is I take the bit, use the mod 9 function, and then once a bit passes through that, sorry, once the this is pointer position though. I need a reader. Wait, but yeah, I'm looking at the pointer's position. Do I need to continuously sum? Wow, this is like a combination of a lot of things in that case. I'm looking for something that accumulates value here. Every single one of these becomes a 1, right? Every single one of these is a 1. Wait. So, okay. A mod function. This will simply take the mod, run it down, and if that mod matches the value here, then we are done. Because we wanted to hit something that's mod 2. Okay, so I'm thinking we need a Y here. Although a Y isn't recommended, I guess I could just use 0 itself to send in a value. So, okay. But how do I... See, the issue is how do I check what exactly to do? I don't know how to... every single one of these are by bit positions, not by bit value. The value is 170, but the position is 60. There's nothing here that can give me the position. Except this, but... Oh! It's the position of the pointer. Oh, so if it points down, it moves it down by 1. Oh, that's not what I expected. That is actually really helpful because you can point backwards and that also counts as a 1. Ah, okay. Still, we still need some good stuff, like... Okay, I suppose every down would add 9 to the pointer. Every forward adds 1, every backward subtracts 1. Can we use a bit that starts off at 0, goes through the following... goes through the... It's entirely possible. Okay, but I do realize for any one of these operations I need either this or this. Okay. Yeah, I just totally did not realize it's an up, down, left, right. Like, I didn't realize that directions. I just thought it shifts it forward by 1, which would honestly have been really useless. But no, this helps. This helps. Okay. So we say if this is bigger than the previous value, in this case, previous value will be 0, I guess. Okay, I also need to figure out the fact that there are ellipses here. These are null, nothings that I guess can be used to send to the output, right? Yes, each of these correspond to an output. It's a 1-to-1. Every single row has 1 input and 1 output. So that's what the ellipses are for. The ellipses become the output. So I suppose since we know that these values can only range from 0 to 8, we can safely first check for the value of an ellipses, right? So first check for ellipses. It's a checker. Ellipses is 181. Okay. If so, ellipses will be sent down while the non-ellipses will be sent over. Okay. So the 6 will be sent over. It doesn't trigger this, but non-ellipses will be sent down. Next, this non-ellipses will be the counter, right? We need to check against the previous value. Is that true? Because if it's a decrease, then we have to go backwards. If it's an increase, we go forwards. So we don't need the modulo anymore, right? Because we can just do this, the number of times equal to this value. Well, no. We have to subtract. Okay. Then if we subtract, so we say 6 towards 2 is 4, we take 1, 2, 3, 4 steps, then we can simply subtract the 2 and take that number of steps. A negative value implies going backwards, while a positive value implies going forwards. That implies that this value is the one that's going to be negative. So let's make that our arbitrary scale. A negative result means moving backwards. A negative value means moving backwards. So we first start with 6, which is a positive value. Now, there is a machine that I once built that helps save values. I think it was in Stack Compiler. Was it? No, it was in Signal Counter. Yeah, Signal Counter. It helped. Yes, this machine over here helps calculate. This machine over here will help calculate whether a value increases or decreases. Yes. See, because here 0 and 0, these two zeros. So these two are the same signal. These two zeros first merge, right, and then they'll check for value of equal to 0, I think. Whereas a 0, 1 here will merge into a 1 and therefore be checked for 0. Oh, this is non-1 basically. So this is the checker for the negativity, or for the positivity. We know that a value will never be 0, right? Because yeah, 2 of the same value means that your oscillator has to go straight down, which isn't possible, I believe. Either that, we're going to just select more or less than 0 in that case, because we will never have 0 as an answer. I think. I don't know if the machine specifically says. It says ranging. Well, I guess it doesn't say that two consecutive values can't be both the same, but we can think of it as what 5 7. Right, this reads to 5, this reads to 7. Wait, what? This reads to 4, this reads to 5, then this would read to 7 down there. Okay. Never mind. Yeah, okay, no, it all makes sense, it all makes sense. So alright, time to build that machine again. So what that machine looked like was first a duplicator. Duplicator then moves to a multiplied by -1, and then a summator, or just a merger. Is it a merger? I don't know, they merge on their own. So first this happens here, and then, but there must be a holding area, yes? The holding area will be released by the next object, and that's why this exists. In the previous machine it didn't have to, but this time I think we have to because our cycle is going to take like, yeah. Sorry, don't mind me. Anyway, the first thing that comes out will be a +6. This 6 will be held on, and then when the next thing comes out, when the 2 comes out, ooh, but yes, I was right. Okay, I was afraid that the ellipses would mess everything up, but we already know the ellipses are being piped down somewhere else. So this will keep going until the 2 come out, and the 2 will release this -6, and that -6 will add with this 2 over here. Wait, this has to be on the same cycle as this, but wouldn't they then merge already? What? Wait, how do I do that? How do I do this machine again? Sorry, I gotta look at this up again. Oh wow, it goes back down to the column at the bottom. What? Okay, I don't know why that happens, but sure. Okay, sorry for having to do this over and over again, but alright, this looks better. So the 6 down here goes, the 6 up here goes. When the 2 next comes out, okay, let's just keep building these machines first. We will try and resolve this later. So the 6 comes out, the 6 triggers the next thing. The ellipses will keep piping downwards until you get the value of 2. The value of 2 will go up, displace this, so these will merge and then we can detect the value. This -4 then means that we'll move backwards by 4. Very nice. The initial 6 though means 6 steps forward, and now we will use our looper. Our looper is somewhere in here. I think it's the size calculator. Wait, is it? No, size calculator is wrong. It's the other one. Sorry, is it gating circuit? No. It's one of 2 loops. I forget which one it is though. It's just the one of 2 loops. Is it Para? No. I like how the music is always different for each of these, but I don't know what binds to what. Alternator? No. Wait, really? Is it just one I just haven't seen yet? Yeah, unwinder, look at this. So this calls 7 times, and for each loop there will be a duplication here that produces an output. So we'll do the same thing here. I think there's another one that did the exact same thing about like the buffer. Is it? No, it's not the buffer. Is it a linked list? Yeah, the one that goes 61 loops, right? I remember this. This goes forward by a number of loops, which will... Well, I don't know what it will do, but it will hold this for a set amount of time, I guess. The heck? Oh, right, okay. Yeah, I don't even know what's going on there. We'll go back to the usual, the unwinder. We'll use this circulation method. So you can see here what happens is it goes into this roundabout circuit, and then it subtracts 1 and detects for 0. So basically what will happen is we'll do the exact same thing. To get to 0, we'll subtract 6 times, and for those 6 subtractions, each subtraction links to a step. Okay. Let's do that. The initial... We could use a Y here. We could use this thing over here. So the initial 6 that comes out can be the first step that goes forward. That can be sent to the 0. The second one will be this ellipses. This ellipses will coincide with wait. No, this 6 is the one that's going to be looped around. Unless I duplicate that first. Because the value itself, or as you can see here, eventually this 2 will have to be used in creating that, right? Either that or just use the Y port. Like using the Y port is valid, I believe. It's also very lazy because I'm just getting rid of stuff here. I'm using non-recommended. It will make things a lot cleaner because I don't have to pipe everything to the same endpoint. But obviously that's cheating. Well, is it cheating? I don't know. I wouldn't say it's cheating per se, but let's try this first, alright? So what happens is that the 6 and the and or this guy will reach the same point. So at this position over here, we'll reach the 6 and the ellipses will take an equal amount of time to reach here. So here it will take this number of cycles. If the ellipses came first, it will also take the number of cycles to get here. They all take the exact same length path. So at this point, everything still tracks by the exact same amount of time. So we can standardize at this point. At this point, everything is still standardized based on the amount of time. Okay. Now this is the looper. The looper can actually immediately start, I think. And really, depending on... One, two, three, four, five, 6. So yeah, it can take 6 loops. So we'll basically subtract by 1 each time. And then for each subtraction, we check for 0 and then send it out in that case. Otherwise, it goes back up. Okay, so question, does it rotate the right direction if it rotates up? Good. That means I can have a conveyor that pushes down otherwise. So it will check for 0 and then it will go down. The issue is that this at the same time needs to activate something that loops through one of these cycles. Okay, I can sort of see what happens. I do need a bit more space though. So in fact what will happen is I think I'll push this up instead. Of course things will be a lot more, well, it won't be that bad. Now I'm thinking about it. I can just reverse everything and everything will be fine. So it'll go up, it'll go through a -1. Sorry, not minus -1, it'll subtract 1 or add -1, or whatever. Actually, I don't actually need the subtract, I can just add -1. I guess it gave me both just to be safe, but the multiply I can't do. I can't multiply by a fraction, so that means I can't divide. Anyway. What was I saying? Right, so how many times are we passing through this? We're passing through this 6 times, correct? I'm going to need a lot more space here, but we're basically checking for 0. And then upon checking for 0, we'll send it out to be destroyed. We'll first set this to continue, but we'll send this out to be destroyed. Otherwise, it'll move down and we'll loop around. Of course, by looping around, it can also trigger this B state. Right? And this B state will basically... Ooh, but no, we need to go for positive and negative. Yes, because again, there are 2 paths. The paths have to differ based on whether the value is positive or negative. If positive, it will have to go through the forward path, which is this path over here. If negative, we'll have to go through this path over here, where it goes down and backwards. So that's a lot of wiring, but it probably can be done. Okay. Issue is that I can't have a conveyor separate into left or right on the same space. It has to be different. So I suppose I have to use the non-one cycle one. Well, no. Hold on. The positive and negative checkers are one away. So that actually works with a one-time thing. Okay, let's shift everything back up so I have space down there to work with. If it takes 1, 2, 3, 4, 5 for positive checker, which we know is this one, then it should also take 1, 2, 3, 4, 5. Okay, well let's make this a little better. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How about here? Wait, no, we're starting from here. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5 would be here. This would be the first one of these. and then otherwise this will happen. Otherwise, or not otherwise, when it's, wait, yeah, and then this will happen, right? So I mean, we only need one checker, honestly, because if this is positive, it won't be negative. So if it passes the first one, it fails the second one. If it fails the first one, we will just pass the second one. So we don't even need the second checker, we'll just go forward. And in fact, that might be all we need. In fact, because of that, we can use the idea that things will only move left or right. In this case, turning right is in this direction. So a positive value should turn this off and cause it to go right. Okay. Any checkers here? No, it's all conveyor, so I can just check like this. Otherwise, it will turn left by default and go here. Okay. And of course, all of these need to, they need to become the product. So actually what I can do is at this very point already convert them into a pixel of 170, which has no color, so it can just stay as that. And then the output can go here, I think, which causes this. And if I timed everything right, which I probably didn't, but let's check. Oh, we also need an output. Let's have the output be... Let's have the output be here. Also, we don't need an output here then, because this already counts 1 when it's duplicated here. So this goes here, goes here. Issue is I don't want this to come out, like... Well, no, well I do want this to come out, yes? I want this to become the pixel, so I want the ellipses to come out. The ellipses will come out. Wait, why is it? Oh, this is an equalizer, it's not a sense. I gotta check for the... Oh gosh. Okay, so this goes sub 1. Sub 2. Whoa, the timings are so off. 1, 2... Oh, 3, 4, 5. Ah, it's because of this. See, a cycle is 1, 2, 3, 4, 5, 6, right? So it should take 6 for this to reach here, which means this had to come out way earlier. In fact, 1, 2, 3, 4, 5, 6 is actually at this exact point. Can I remove this? Will it turn right? I don't know. Will it turn right? Let's check. Yeah, she will turn right, so I can just place this here. Okay. 2, 3, 4. Okay. 1, 2, 3, 4. Wait. Wait. I'm getting confused now. Because this was supposed to be at the same time. Wait, oh, now it's 1 off. This and this are not on the same cycle anymore. So this is 1 off, meaning that this should be later by 1? Or earlier by 1? I don't actually know. No, it should be earlier by 1. I don't like it's earlier by 1 because the 6 doesn't sense it anymore, so this won't do anything. Oof. Okay. Well. That's really unfortunate. That is exactly 1 off. Oh, because it starts 5. 1, 2, 3, 4. Wait. Oh, okay, it's 6 from here, not 6 from here. It's 1, 2, 3, 4. Wait. 5. Should have been here, yeah. Okay. Well, I could always just make this a little longer. I don't know. This is exactly why the output should be here, or the next caller should be here, because we started from here. This is where the loop starts. Okay, so what I can basically do is make this loop a little longer. Okay. Let's make this loop a little longer by just shifting the entire thing up. I could definitely also have shifted it, flipped and shifted it down, but shifting it up is easier for me. So by shifting it up by 1, the timing now works, yes? Yes. Does the timing continue to work? No, the timing is now off by 1. Why? Is it because initially this takes 1, 2, 3. Wait. 1, 2, 3, 4, 5, 6. Okay, because this is one later now. This still has to be one early. This is always one late, so it doesn't matter how far up this goes. It will always be off by 1 at some point. Okay, and then if it keeps going off by 1, become off by 2, then off by 3, and then it will just not work. I don't want to go like I don't want to make this a consistent triggerable conveyor because I don't want weird things to happen. I want that to only be. I want this to only work when this exists here. If it's sent out, then this won't work anymore, and we consider nothing happening. Right? Ah, this timing feels very off though, because like at this point. Well, no, at this point, the same thing happens. I don't think I have to worry about this section. This section should work fine. It's just about this section. If this happens, the 6 just won't pull out anything. Okay, if I had a space here before the duplication, can that change anything? I can shift the entire thing right by 1. Is it now valid for me to put 1 here and 1 here? No, it's off by 1 now. Also, why did it shift by 2 first? What? The initial 6... Oh, the initial 6 already shifted it by 1. Oh, oof. Okay, my idea is entirely wrong at this point. I need to not shift by 1 first? But how's it gonna do that? Maybe the Y... Okay, maybe the Ys would have been way better here than the ellipses, honestly. Yeah, the Ys are way better, aren't they? It needs to not shift by 1 first. So an X produces 1 at the beginning of the simulation. Okay, so let's do that. Let's do that. Instead of using the ellipses, let's cut the ellipses. Get rid of them. So how do I get rid of the ellipses? I'll just have the ellipses lead to a dead end. Okay, let's shift this entire thing back to its usual position here. And we'll use some bits to help us. So, alright, we still want to keep the essence of this idea though. So let's get rid of some of this wiring. Okay, all this should still stay the same. Okay, even with the X bit, something feels a bit wrong. Well, no, the X bit can just produce its first bit and then just stop working after that. Yeah, you know what? Let's cheese it. Let's make an X bit that just turns into a 170 and cashes it in. It just cashes it in as the first bit. We have to do that. The Y bit is the one that we triggered by this. So the Y bit is only triggered 5 times, isn't it? 1, 2, 3, 4. No, the Y bit still works 6 times. Then 4. Yeah. So there is still a 6 times of Y bit. Which means that... Whoa. Why are we checking for negatives and positives? Oh, that might be a difference here. Wait, I forgot. If it's a negative 4 coming out, then the -1 won't work. We do a +1. Okay, well that's not that challenging. I just use a conveyor instead. So what will happen is there will be a check for positivity and negativity. The duplicator is no longer needed. Okay, let's try this again. So first there will be a check for positivity or negativity, which will then be fed into this. Same thing happens here. If positive, we'll move it down. If negative, we'll move it forward. If positive, it will go through the first loop, and the first loop will simply subtract by 1, check for 0, and then check for 0 first. We wanted to work 6 times, so if I check for 0 first and then subtract by 1, it's probably better for us. Oh no. This will turn right by default, right? So I turn it off. It will... If I turn it off, it will go right by default. Yes. What the heck? No, this is 170. There you go. So this is supposed to turn right by default, otherwise it will be pushed down by the conveyor. Good. So once it reaches 0, it will be pushed down by the conveyor. The 0 can also happen to activate the Y. It can activate the Y. And then the other one will do the exact same, but will also activate the conveyor. Right? So right now this should be inactive if it only connects to the Y. If it connects to both the Y and this, then that will be counted as... I don't know what that will be counted as, but we can do the exact same thing here and then destroy it. So here we do the exact same thing. We check for 0. We have this guy. This guy will be inactive first. Oh, I guess go active first when 0 is recorded. Yeah, okay, this should make some sense. Subtract by 1. And then if recorded as 0, goes here. So what happens is, if it checks a positive, it will move... Oh, I need to connect these. If it checks a positive, it will move forward, or move down. It will go through this cycle where Y is... Oh, wait, hold on. Oh, okay, don't subtract by -1, subtract by regular 1. Gosh, dang it. There you go. So I don't need to go down again. I don't need to go right again because putting in something into the input already pushes it forward by 1. So all I really need to do is to go down and that's it. This one I need to go down and go right twice. That is kind of an issue. Okay. That's a bit of a bigger step. Because whenever something goes in, it'll be pushed forward. So to go backwards, you need to go down and backwards twice, not just once. Oh, this should be the opposite. This should be non-negative. Oh, wait, then that messes things up. Okay, let's do this then. Hopefully that works out. This has to check for non-negative for this to function. Okay, and then there should also be a pixelizer. By pixelizer, I just mean equal 170 is all. In fact, I'm not even sure this pixelizer is a real pixelizer. I'm pretty sure this is just a full battery symbol. Like, I'll show you later that there are other versions. Oh, what? Oh, this should be non-active first then. So that it pushes back up. Yeah, and then this goes 6 times, right? And this won't activate anymore, go forward. But before it goes forward, it has to call out the next object. Oh, but look at this. The next object will be the ellipses. The ellipses have to come out as well. So instead what I'll do is probably call the object out every time this happens. Yeah, alright, so this has to be a bit of a longer cycle then. Okay. That's fine. Ooh, longer cycle does mean kind of weird stuff happens though. But this should be okay. Then there should be a caller here for that. Alright, so let's try this again. This one should be, again, firstly a non-negative counter. That counter will link to everything. There should also be a caller for the next object here. Okay, so it calls out the 6. Every time it calls out the 181 should be discarded. This one will also come at the same time. And so it will call out 6 things, right? Which means it will call it the 2 next. Or will it call out the 2 early? Ooh, it'll call out the 2 early. Ooh. I don't know about that. Maybe the... Yeah, it calls out the 181 earlier. It has to go... It's to not call 1 that many times. How do I do that? This can be checked for greater than 0 sign, but make a check for greater than 1. This will call the object 6 times, but I only want to call ellipse. I only want to call 5 things. How do I do this? Well, okay, it's not that challenging, I guess. What I can do is call something out first and have it... Sorry, I can activate Y first and then call 5 times. Okay, this will make things a little bit more complicated, but I can work with that. Alright, so... what I want to do now is cheat. I want to subtract by 1 first. Subtract by 1. And then activate Y. So let's activate Y on this red line. Subtract by 1. And then we'll have the loop over here. So the loop will follow this basic pattern as well. So we'll do this. It have to be pretty long. Congrats, we can now put this R over here, which makes things better for us. This will be inactive. This will be active first, and then inactive when... Oh no, this has to be inactive first and active when non-zeros are detected. That happens. Wait, but this B would also activate this. Wait, what? Uh-oh, that might be an issue. No, the 0 comes right before this, so the B won't even affect this thing. Okay, then subtract 1. Wait, why is oh, we need a caller, right? I was like, why do I need such a big loop? It's because the recorder must exist here. Okay. So this will cause us to only call the 5 things out. Call once, call twice, call thrice, call 4 times, call 5 times, call 6 times. Yeah, no. Calling 6 times. Wait. How many times is it called? Once, twice, 3 times, 4 times, 5 times, 6. It calls 6 times, but why does it... I'm sorry, why does it only... What? Wait, 1 ellipses, 2 ellipses, 3 because there are 5 ellipses. It does call out 6 times. The previous one called out 7 times. I don't know why that's the case. But okay, we can just duplicate this thing over here. Okay, cool. And then, okay, let's rebuild this. We can actually just copy this exact design here. And I think copying should just work exactly the way it should work. Okay. Honestly, I could probably flip the entire design, make it slightly faster. I don't know if I should though. Crap. Dude, please. Okay. This one I can pull down slightly, I think. Can pull down slightly to make it so that the output can exist, or the output can just exist here. So we don't go red here, we go blue. And then the red we can get rid of. Okay. So what happens is here it will add 1. These are all adders because we are negative here. So these will add 1. Add 1. So every time it adds 1, B state on both of these, yeah. Okay. So this will call 6 times, call 6 times. So this is correct. Yes. 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 Next, the 2 goes in, detects a -4. It will do this, and it'll go forward. Ooh, okay, the opposite must be the case then. Yeah, okay. I'm hoping that this works, otherwise... okay, 2 comes out. The 2 comes out, the 2 goes up. Oh, whoa, what the heck? Wait. Oh, the down doesn't need to exist, does it? Wait, the down does need to exist. Why does the down exist twice? Sorry, let me just check this again. Is there one that comes out here as well? There's a second down that comes up before the... Okay. Okay, so what if I flip these so that I can make this come out later? I don't know, this is very like cheesy, but let's hope it's fine. So, okay. This comes out. This... Okay, good. Ah, it pushes down early. This has to be a lot later. Okay. Backwards first doesn't come either. This has to be late. Wow. Ugh, okay. Fine, I can do that. I simply need to shift all of these one to the right. And then add some wires. I can actually just... Oh, I don't want it to touch this B though. Alright, this probably makes a bit more sense. Of course, I do need a longer wire here because I do need to lengthen the amount of time as expected. There you go. Happy? Unfortunately, this is as fast as it gets without breaking anything. So this conducts 1, conducts twice. Ah, what? Why is it? Why? Oh, breakpoint reached. Okay. Does it have to be even longer? If it does it, okay. I don't know if it works if it's even longer or not, or if it just breaks. Okay. There has to be some more another elegant way of doing this. It didn't work. It didn't fail the first time because the first time this cycle was short enough. Right, when the next thing was called, this already have entered. But because we need 3 of these, this will be much longer, which means that the caller here should be later? No, this symbol should be later. Okay, what if... this plus has to be... this symbol should be a lot later. Okay, can I shift that late symbol forward? Kind of. Kind of, but there are a couple issues with that. Right? Adding 1 here makes this whole thing a lot more. If I added 1 before, it will kind of make things a little worse, I guess. Wrong button. Okay, this should start off as inactive first and go straight up. Sorry, breakpoint. So what happens here is this -4 will come out here. We'll first sum 1 before the next thing comes out. So this will be a lot later. The issue is that this will cause a lot fewer things to occur because this +1 will occur before the 0 is checked. So you'll get 1 less output, yeah? Yes. So this will not instead be equal 0, have to be equal equal +1, I think? Or greater than 0. Right? Just have to check for greater than 0. Wait, smaller than 1? It was the other way around. So keep going, and even if it hits 0, we will still count that. If it goes after 0, then and only then will it stop. Yes, looks like it. Okay, this works. It is very scuffed, but it works. Now, can I shorten this? Yes, I can. Okay, very good. That means I can shift this entire thing back. Nice. Of course, I just want to save space is all I want. Let's get rid of this wire here. Okay, this should be good. Alright, this is a machine that works. How small of a space can I cramp it in? Pretty small. I can push this in here to cramp it in here. I guess I can put it up here and make it look nicer. Alright, yeah. Can I make this better? I can push this up. Yeah, okay, hold on. Let me think about how I can make this slightly better. Right, because this is... yeah, this entire thing can be shifted up. Okay. This can be shifted up. This will cause this to happen. Just do that. White wire goes here. This can also be shifted up. The way I will shift it up is this goes here. Okay, so let's try making this slightly better on ourselves here. This will go here. This will... Okay, hold on. This will go here, this will go here, then a checker, then back. Okay. So the path taken will be this. Yep. Okay. Ooh, this B is in a bad spot though. Okay, hold on. That's kind of bad. Okay, I might as well just go back to my old original setup. If it works, it works. I can shift this up though, and I can shift this over. That saves a lot of space. Yeah, okay, red goes here, blue goes here. There you go. Can red take this path instead? I think that's a lot nicer. And of course, because I want to make things look really, really nice, red can take this and then blue can take the other one. I'll show you why. Oh, actually it doesn't matter, okay. Well, if it doesn't matter, I'll just go back to this. Yeah, okay. This looks like it works. Yes. Yeah. Whoa, what the heck is going on with that reading? Oh. Oh yeah, sorry, this can't be. This has to go down and here a bit as well. I don't know why I left those out. I don't know, I can only wonder. So anyway, this should work, yes? Yes. Okay, does it work forever? Cool. Alright, I really wish I could just save some space here. This looks very cluttered. But alright, this works. Oh, wait, error? What? Why is there a sudden error? Okay, let's breakpoint here. What is wrong with my machine? There's an 8. There's a -8. Okay, so what is it checking for again? 5. 5 and 8 goes -3. Why did it... Wait, what? Why did it send it back up? Where's an up arrow? What? Oh no, that's my breakpoint. Because when it hits 0, it loops. Wait. If it loops, then what happens here is... It goes... down. It can't go... Okay, it goes down. Goes back, it goes back. Huh. Is it because there is already a pixel here? If so, that's nasty. But if so, I can also fix it by just making it so that the leftwards go first. In this case, what will happen is that instead of flipping over to the next page, it will go back to the previous line and then go down. And that fixes everything. Jeez, that is such a random... That's such a random thing to have. Weird, am I right? Oh, okay. That was a final hiccup, but I guess it worked out. I kinda... not very certain about it, but it works, it works. Just watch it again. Proof. That was a very weird edge case. Huh, I've never seen that kind of thing before, but I guess it works. Cool. This level is also quite fun. Pretty different puzzle than the rest, so I will appreciate it. Hey, that's 32 valid segments. I don't get a new piece of lore. Have we seen this? Yeah, no, I've read this before. I've read this in the voice. Okay. It looks like my cycles is doing pretty well, but in terms of icons I've used a lot, and in terms of space I've also used quite a lot. That makes a lot of sense. This is very big. Not outside the bounds of the level though. And I guess I could maybe work over time to fix this. Yeah, it should be fine. I can actually just mess with the Ys and stuff. Alright, I'll probably work on that. But until then though, I think this is going to have to call an episode. Yeah, well, it's been almost an hour. Alright, we'll do Road to the next episode and we'll see how that goes. Until then though, hope you guys enjoyed the video. I'll see you guys next time. Bye bye.